Okay guys, today's lesson is on refraction. You're going to need something to write with, something to write on, and your attention span. Make sure you're focused on what we're doing. You guys know how to use these by now. Pause the video, answer all of those questions, check your answers, and rewind and rewatch the explanations as much or as little as you need to. Let's get started. Okay guys, so with refraction, we're going to start just with a couple of examples of what it looks like in real life before we really define what it is. So we're probably used to, if you've been to the zoo or you've been to see penguins, especially in the zoo, you might look through and you see kind of half water and half above. And you can see that images don't quite line up when you're looking through the air and then when you're looking through the water. And you especially see this if you've ever had a straw in a glass, which I'm sure most of you will have. You can grab a pencil and put it in a glass cup now and have a look for yourselves if you want. And you can see that the image of the straw just doesn't quite line up. It doesn't match. Something's going on to the light, okay, between the glass and the air. That means that it doesn't appear quite right. Now, if we make a ray of light from a ray box, a lot of us will have done this in class, you can see what's happening to that ray of light as it's going between the air and the block. This is the same thing that's going on between the air and the water. The light is bending as it's going between the two different mediums. Now let's have a look at what's going on in more detail. So what we've seen from these images is that when light goes from one medium to another, so for example, if this side is air and this side is water, if that medium has a different density, okay, so water, the particles are more tightly packed together than in air. Because of that difference in density, when light passes through that medium, it will change speed. Okay, it slows down as it goes into a denser medium, and that change in speed at that point causes it to change direction. So let's label up and draw a diagram of what we saw with the ray of light going through our glass block. So we have our ray going in, same as before. The ray of light going in is an incident ray. We can draw our imaginary normal in there. As the light goes into a denser medium, it slows down and it will bend towards the normal. It only bends at that point where the medium changes. Once it's bent, it will continue in a straight line. That is now the refracted ray. And now we're hitting another point where it's going to change medium. This time it's entering a less dense medium as it's going back out into the air. Because it's less dense, it's going to speed up. And when it speeds up, it bends away from the normal. That's now our emergent ray. Again, notice it's only changing direction at the point where the medium changes. Otherwise, it continues in a straight line. Here are your key points to embed. Make sure you've got that diagram down and you know what happens as it goes into a denser medium and a less dense medium. All right, guys, self-test yourselves, look through, say in your head, check what you've got, or get someone else to quiz you. Here's your independent practice. Do your best with these. For question number 5, make sure you've got at least 4 points down there to get all 4 of the marks. Here are your answers. Hopefully you got them all right. If you didn't, you know what to do. Rewind, check, see where you went wrong. But if you're happy that you've got everything and you know it all, then that's all for today. Well done, guys.